Okay, I think I'm recording. So let's go here. This is a topic that 5 students in the class have attempted but unsuccessfully. I'm going to assume that they're stuck or they might be stuck. So let me show you what's going on here. What I'm going to do is take, first of all, a screenshot. I'm going to go back and forth here. It's going to be a little confusing perhaps, but I want to be able to write over top of it, okay? So when I get something like this, I'm being asked here to predict which direction this goes, to the right or to the left, right? To the right or to the left. And so I have to look at this and say, well, I don't know what's going on. First of all, okay, I see. It's an acid-base reaction. It's an acid-base reaction. And I'm going to have a pKa table over in the corner. And I'll look those up in a minute. But before I do, I'm going to identify which is the acid and which is the base. So I see what normally is a base here. That's an amine. That's normally a base. And then I have water here, which is both an acid and a base. But the question is, what's it acting like here? Pardon the background noise. I got a piece of something in my keyboard. Okay, I think that's gone. All right. So I got a base here, which is normally an amine, which is normally a base. And then I've got water, which is either. So I'm going to go over here and I'm going to look at it. And I see, aha, okay, if it's amine here, it's an ammonium here. Okay, got it. So this is the acid over here. And this is the base. All right. And so water, aha, okay, here's the extra, here's my hydroxide, which is a base. I got what's going on now. Okay. So now my next goal here is to go look up the pKa of this and the pKa of this. And whichever is the stronger acid gets to act like an acid. So if the ammonium is a stronger acid, then I know it's gonna overwhelm the water and it's gonna go the other way. So if ammonium is the stronger acid, it's gonna go that way. So I'm gonna look up the pKa's. I know that ammonium is a stronger acid because water is not a strong acid at all, right? So I know for sure this one's gonna go this way. But let's go look it up. I'm gonna now go over to the browser, which is gonna look a lot like that. Got it? Okay. Here's the same reactions here. Okay. I'm gonna look up in my tables. Look for pKa table. Hopefully that'll be easy to find. There it is, pKa's. Okay, now I'm gonna look for something that looks like this, an ammonium. Okay, so hydroiodic acid, there's hydronium. Oh, there's an ammonium. All right, it's 5. And here's ammonium with, this is an anammonium, this is aniline. This is ammonium, right, for the conjugate acid of ammonia, and it's 9 and 5. So this looks more like the bottom one than it does the top because it's not conjugated to anything. So I'm going to come back over here, 9, and I'm going to write in here this is 9. Then I'm going to go look back to the browser again, look for water. What's the pKa of water, right? And you'll do this so many times this will be memorized. That's 14. So this is 14. Oh, I was wrong. I don't know what I was thinking. Okay. So the lower pKa is the stronger acid. No, that was correct. Okay. The lower pKa is the stronger acid. So we're going to go from lower to higher. And so this is going to go to the left, right? The lower pKa, I'm not sure if I'm saying that right. The lower pKa is the stronger acid. And in case you forget that, you can go look at the table. Let's go back to the browser for a second. Let's go back to the browser. And these are the strong acids down here, right? And so they've got the low pKa's. Those are strong acids, and these are not strong acids down here. These are terrible acids. So yeah, you remember the lower number is the stronger acid. So it's going to go in the direction. That's going to go to the left. Let's go back to the browser. I'm going back and forth, and I'm going to click left. Now let's do the next one. The next one is a carboxylate. I can see that. And hydronium. I know, and I see here's a carboxylic acid, so I can do that one without. I know for sure this is the acid. Right? And this is the acid over here. So I'm going to go look up a carboxylic acid, and I'm going to look up hydronium in my pKa table. My pKa table is still open. Hydronium should be easy to find. There it is. It's 0. That'll probably eventually get memorized on accident. All right, let's go to blue. This is 0. And a carboxylic acid is, that looks kind of like a, yeah, you know, you got to get your eyes used to this. Oh, there's a carboxylic acid. There's acetic acid. That's 5. Okay, that's clearly higher. We're going to go from the lower to the higher. The stronger acid gets to act like an acid. So that's going to go to the right. Okay, I'm going to do one more here. No, I'm going to do both of these. Okay, let's do another one. Ammonia and ammonium. So this is normally a base, but you can see here's one with the H plus stripped off. So that's actually the acid. Not expecting that. Here's an acid. And here, over here, I can tell that's the acid. So it looks like I've got an alcohol and I've got ammonia. And I'm going to pretend like I don't have those memorized. I've done these so many times. Ammonia is down here. There's ammonia. It's 38. That's 38. Let's go back to blue. Okay, and then an alcohol. So, and you're gonna be tempted to look for that exact alcohol, and you've got to get your eyes used to this. There is an alcohol right there. So this is about 16. Now, if it bothers you that we're not getting that exact alcohol, look at the difference between these two numbers, 16 and 38. That's such a big difference. It wouldn't matter if I said the pKa was 17 or 10 or 18. It's going to be way lower than 38, right? So we're going to go from the lower to the higher, and that's going to be going to the right. To the right. Here's another alcohol, and here's a strong acid. Okay, I'm sorry, that's not an alcohol, that's an alkoxide. Here's the alcohol, right? We can do that in our heads. That's the acid, and this is the acid on this side. Okay, and this is a strong acid, so it's gonna be like negative something. Let's go back to the same colors. Let's keep our colors. Here's an acid over here, and here's an acid, right? And so the strong acid is gonna be like -7, -8, and this is gonna be about 16, because we had, right, remember that? An alcohol over here was about 16. Let's stick with our colors. 16. And this is going to be, oh, I don't know, -7, negative something. You know what? You're not supposed to have this memorized at this point. Let's find HCl. HCl is -6. Okay. -6. So clearly, can you see it doesn't matter if it's -6 or -7 because we're comparing it to 16. -6. Clearly, we're going from the smaller to the bigger. It's going to go to the right. Oh, this is a good topic. I'm really glad you're wrestling with it. And let's check that just to prove to ourselves we got it right. Okay, let's try another and see if it has the same form. It does. Same form. Try another. Same form. Okay, that's all we're going to do with this one. I hope that's helpful. Find out which one's the acid first. Then go look up the pKa's of those acids. And then point the arrow from the lower number to the higher number. Because the stronger acid gets to act like an acid. Okay, good luck.